So in this video of quadratics, we're going to be continuing on the idea of factoring, and today we're going to be looking at special product rules, which can help us in a number of ways when it comes to quadratics. This is Algebra 1, Erudition Education. Let's get started. So let's ask ourselves the question, what are special product rules? When factoring or expanding quadratic equations or polynomials in general, there are certain relationships which we can use to factor and expand more efficiently and easily, as opposed to just doing regular expansion or FOIL. These relationships can help us convert quadratic equations from the standard form to factored form very easily, and help us find the roots to the equations rather easily when these product rules are applicable to these quadratic equations. These special product rules, as noted in the name, are special. They're not applicable to all quadratic equations, but to those quadratic equations that they are applicable to, they can make our lives a lot easier when it comes to converting from standard to factored form, or also when we're just talking about factoring and expanding the polynomial or quadratic equation or expression. So in this video, we're going to be talking about the special product rules of difference of squares, squares of difference, and squares of sum. These are the three special product rules that we're going to be talking about, as they are very helpful. So let's start off talking about difference of squares. So the difference of squares formula is given as a squared minus b squared is equal to a plus b times a minus b. Let's check this and expand the factored form right here and see how this is the case. So let's just do normal FOIL. So a times a plus b times a minus b. Let's FOIL it out. So we'll get a times a, which is a squared, plus a times negative b, which is negative ab, plus b times a, which is ab, plus b times negative b, which is negative b squared. So when we continue this, the negative ab and the plus ab cancel out, and we just get a squared minus b squared, as can be seen by this difference of squares formula. So let's use this difference of squares formula in this first example. As always, try it on your own first, and assuming that you've tried it, let's do it together. So the question is asking, factor the following quadratic equation, y is equal to x squared minus 4, using the difference of squares rule. Knowing that the difference of squares rule, a squared minus b squared, is equal to a minus b times a plus b, let us dive into this problem. So in this case, our a squared is x squared, and our b squared is 4. So we can break this down into x minus 2 times x plus 2. And this is the factored form of this quadratic equation using the difference of squares rule. Let's look at our second example. Once again, try it on your own first, and assuming that you have tried it, let's get started. So different from the previous example, in this situation, we're being asked to expand the following expression using the difference of squares rule. So we have been given, in the difference of squares rule, that a minus b times a plus b is equal to a squared minus b squared. In this case, our a is x squared and our b is 9. So if we write it out, we will get x squared plus 9 times x squared minus 9, which is equal to, as given and denoted in this formula, a squared minus b squared. Since our a is x squared squared is x to the 4th. So our a squared value will be x to the 4th. And since our b value is 9, and 9 squared is 81, our b squared value will be 81. And thus we will get x to the 4th minus b squared, which is 81. And this is the expanded form of this expression using the difference of squares rule. Let's look at our third and final example on this topic. Once again, try it on your own first, and assuming that you've tried it, let's dive into this problem. So we are being asked to find the value of 51 squared minus 49 squared using the difference of squares rule. Once again, given that our difference of squares rule says that a squared minus b squared is equal to a minus b times a plus b, our a value is 51 and our b value is 49. So therefore, 51 squared minus 49 squared will be equal to our a value minus our b value, which is 51 minus 49, times our a value plus our b value, which is 51 plus 49. In this case, this will simplify to 51 minus 49, which is 2, times 51 plus 49, which is 100. And thus, our final answer will be 200. Using the difference of squares rule, we've simplified this seemingly complex expression into this simple, clean number. Now let's look at the square of difference and the square of sum. So the square of difference and the square of sum formulas tie hand in hand, and they are very similar. The square of difference formula can be given as a minus b squared is equal to a squared minus 2ab plus b squared. And very similarly, the square of sum formula can be given as a plus b squared is equal to a squared plus 2ab plus b squared. Note the similarities here. All of the values are the same except for the difference in sign on the middle term. Let's check these as well and expand the factored form and see how this is the case. Let us start with the square of difference formula. In the square of difference formula, we will get a minus b times a minus b. And let's FOIL this out. So we will get a times a, which is a squared, plus a times negative b, which is negative ab, plus negative b times a, which is negative ab, plus negative b times negative b, which is b squared. So from here we will get a squared minus 2ab plus b squared, which can be seen here as well. Now let's expand and FOIL out the square of sum formula. The square of sum formula is given as a plus b times a plus b. And let us FOIL this out. So we will get a times a, which is a squared, plus a times b, which is ab, plus b times a, which is ab, plus b times b, which is b squared. In which case we will get a squared plus 2ab plus b squared, which is the same as denoted by this formula. So let's work on examples regarding the square of difference and square of sum formulas. As always, try these problems on your own, and assuming you've given them your best effort, let's dive into this problem. So, we have been given 4x minus 4 squared, and we are being asked to expand it using the appropriate formula. Since we see a negative sign here, we know this is the square of difference formula, which can be denoted as a minus b squared is equal to a squared minus 2ab plus b squared. In this case, our a value is 4x and our b value is 4. So, from here we will get 4x minus 4 squared. The square of our a value, or the square of 4x squared, is equal to 16x squared. Minus 2 times our a value times our b value. So our a value times our b value is 2 times 4x times 4, plus our b value squared, which will be 4 squared, since our b value is 4. In which case, we can simplify to 16x squared minus 32x plus 16. Let's look at our second example on this topic. We are being asked to factor the expression 4x squared plus 8x plus 4 using the appropriate formulas. So the first thing we can do is, since we know that a 4 is present in each of these expressions, to make it easier, we can first factor out a 4, in which case we'll get 4 times x squared plus 2x plus 1. We just factored a 4 out of this expression. And from here, since the middle term has a plus sign, we can see that this is the square of some formula. Our square of some formula is a plus b squared is equal to a squared plus 2ab plus b squared. Since we have our a squared and b squared values, we can simply find the square root of each of these and plug them into this factored form. So here we will get 4 times the square root of our a squared value, which is x, plus the square root of our b squared value, which is 1. The square root of 1 is just 1. And thus, we have the factored form of this expression. So now let's think about putting all of these formulas and rules together. So once we've learned the individual formulas, we can use them to expand larger expressions much more quickly and much more efficiently. Additionally, we can use these formulas to help us factor large expressions much more quickly. They also help us to find the roots of quadratic equations quickly compared to using the Vieta's theorem. So let's look at these practice problems. I'm going to solve the first one here with you and do the other two on your own for extra practice to master the concepts illustrated in this video. So let's look at this factorization problem. We are being asked to factor the expression x squared plus 2xy plus y squared plus x squared minus y squared. So what we can do is we can break this into two separate expressions. X squared plus 2xy plus y squared plus x squared minus y squared. And from here, we can immediately see two formulas being usable. In the case of x squared minus y squared, we have difference of squares. And in the case of x squared plus 2xy plus y squared, since the middle term has a plus sign, we can see that this is the square of a sum. So from here, we can work on these two. For x squared plus 2xy plus y squared, we see our a squared value and our b squared value, and we can simply plug them into the formula for the square of a sum. So, since our a squared value is x, our a value will be x. And since our b squared value is y squared, our b value will be the square root of y squared, which is y. And this is this part of the expression factored. Now, let's look at the second part of the expression, the difference of squares. Since we know our a value and our b value are simply the square roots of these two values illustrated here, our a value will be the square root of x squared, or x. And our b value will be the square root of y squared, or y. From here, we can simply plug them into the formula and get x minus y times x plus y as the factored form for this expression. Now that we've factored these two individual expressions, we must string them together. So, as we can see, an x plus y is present in both of these expressions. Therefore, we can simply factor an x plus y out and sum up the other two. So here we have x plus y times x plus y, and here we have x plus y times x minus y. So we can factor out an x plus y since it's present in both of these, and we'll get x plus y times the sum of these two, which is just 2x. And that is this expression in factored form. So, finally, let's talk about upcoming topics in quadratics. So now that we have an understanding on the crucial idea of factoring in quadratics, we're going to explore new ways to solve quadratic equations in future videos such as completing the square, quadratic formula, and square root. Thank you for watching. Please like or dislike our video, and feel free to comment about anything that you think should be covered, such as topics or specific details about certain topics. Also, feel free to subscribe. Please subscribe. And thank you for watching this video. Until next time.